Okay, so I'm going to give kind of an overview of how Monte Carlo works, and this is a terribly biased talk because I'm going to explain how MC Wrapper works. For those that are new, MC Wrapper is a series of scripts that really, I'm trying to make it kind of a one-stop shop for simulation for GlueX and Hall D, which means it should be able to run the production chain. So in the first talk from Margito, from generation through plugins, so we've now heard about HD root and plugins. It needs to be able to run HJONT3 or HJONT4, so the JONT3 and JONT4 versions easily. This is becoming kind of less important as we make the transition. I want it to provide some basic standards of simulation, so we can compare apples to apples. When two people make a simulation, we have some record and some provenance about what the settings were. It needs to be customizable. I want it to be able to use various batch systems, and I also want to provide support for new users. So what is the production line? What does it look like? Essentially, there are kind of four modules to get Monte Carlo. You start with your four vectors at the generation. Those get fed into JONT, which actually does a simulation of the detector responses. The output of JONT gets put into smearing, which you can kind of think about as tuning. Oftentimes, JONT is pretty clean and pristine, and we need to kind of smear it. We need to muddy it a little bit to make it look more like data. And then finally, the output of MC smear, or the smearing step, gets fed into HD root. This is where reconstruction happens when you say, I want to run my plugins or whatnot. MC Wrapper also allows you to take a pre-generated HDDM, and each step provides output. By default, most people tend to deal with the reconstructed as output, or as we'll see later, you can even go to the trees via the reaction filter. So I was going to go through and update my list, but I thought that's kind of a fool's errand. Basically, MC Wrapper supports a set of generators. This isn't an exhaustive list. You can go to the documentation where I have an exhaustive list. Documentation will be given at the end. But if you have some very peculiar generator that you've implemented on your laptop, say, or interactively in your own workspace on the farm, out of the box, MC Wrapper will not know how to deal with it. You can write me. It's usually not hard to get it working. So the one big thing in generation that MC Wrapper does is it actually utilizes RCDB and CCDB calls. So this is our run conditions database and calibration constant database. So before, you would have to fill out things like, like radiation thickness, or the coherent peak position, or what the electron beam energy was, and several other things. And I am terrible at making typos and mistakes when I'm copying this single value into three different places. So I made MC Wrapper actually look up the numbers for you and plug them in on your behalf. So it really takes the legwork out of grabbing the right values for a given run number. A special note, the generator has to be able to utilize these values in order for the wrapper to control them. So if you have a new generator and you've hard-coded the electron beam energy, and then you're wondering why its implementation in MC Wrapper isn't using the beam energy, that's on you. Like, you need to make it in a generic way so that it has the hooks for MC Wrapper. Special new compared to last year, there's a beam properties class. This is written by Justin. It was incorporated into the wrapper as of 2.0.4. So it actually uses a configuration file that holds all these properties specifically to the beam. MC Wrapper will write this for you. So actually, if you were using MC Wrapper and you kept it up to date, nothing changed with what you did. But under the hood, actually, it began to use this beam properties class. There are essentially three flavors of this kind of class. You can ask for cobrims. Cobrims is the original way we we used to do things. It gives a theoretical calculation of the flux and polarization from a model. CCDB, actually we'll use the flux from the CCDB. Special note, this can lead to a truncation in thrown beam energy if you paid attention to the help list. It's something like 6 GeV. You can correct me if I'm wrong. Basically, if we don't have acceptance in the PS or the counters, we don't have a flux to record. Justin has a note on his documentation page that on the wiki, and he makes a comment about these stuff below this not being available kind of default. You can also supply a custom file and histogram to say if the flux looked like this, and it will utilize that as well. This includes polarization. So the user choice for this is controlled in the MC-wrapper config file, which we'll deal with in just a little bit. Basically, there are 2 additional optional parameters. There's flux to gen, which you can set to CCDB. This is actually the default. Most of the time, we want to reproduce data. We don't have a tagged flux that low, and you're doing a cross-section measurement. You're not going to have, you're not going to be sensitive to that part. So pull from the CCDB, but you can say, hey, flux to gen, give me the cobrams, and you'll go back to the original, as well as giving the file and histogram name. This is actually the full path to the file and the histogram name to use it, and it works for both the flux and the polarization. How might you make the histogram for polarization? This is actually a link to a tarball that contains instructions on how to generate a histogram. So you can actually, in MC-wrapper, use polarization from the t-pole. So after we do generation, we move to JAUNT. It supports both HDJAUNT, HDJAUNT4. It also uses RxCDB and CCDB to fill out many of the settings. These are called cards in the lingo. If you actually dig and look at these control.n, these are various cards, which is just really like a configuration. These are actually the same calls that were made before, so there's consistency. It's not making two different calls. It makes the call once, and it uses it in both places. So this keeps weird edge cases from happening and the like. This also, at this step, we can add in or remove backgrounds depending on which direction you're going. So the current best practice is to use these random triggers. So when we're actually taking data, we have a random trigger. It's really asynchronous, and it just is reading out all the detectors every so often, and we convert those into HDDM, and we can merge. This is actually really in the smearing step, but this is where the background kind of comes in. It's at the hit level, so it's kind of with JAUNT. There's an old beam photon background, which since we have random trigger, if you're going to do background, don't do this one unless you really need to. You can also supply custom files, so you could take data and overlay it at the hit level in the next step, like random trigger. And then there's also an option that we can see later, tagger only, which is basically doing this background, but in the tagger only, also not needed. So there is a known issue that I wanted to bring up. This issue number 103, this is a link. It's still open, last I checked. So this actually affects running MC-wrapper with a pre-generated HDDM file requesting HDJAUNT4. So we'll actually see how you fill out the form. Essentially, when you supply MC-wrapper an input HDDM file, it's clever enough to figure out, I need to make it 10 jobs, and each job should run over a different tenth of that input file. So you don't have to break your data apart. It will deal with all of that. It does that by utilizing the skip card, which is in the control.n file. Problem is HDJAUNT4 ignores the skip card. So MC-wrapper tells JAUNT, hey, skip 20,000 events, and HDJAUNT4 doesn't listen. And so what you end up getting is MC-wrapper repeatedly running over the first set of events. So MC smear is the next, that third box. It's kind of tightly coupled in my mind to the prior, the JAUNT. Um, it takes the output of JAUNT and smears it, and it tries to make this pure Monte Carlo look more like data that comes from the actual detector. MC wrapper will actually configure MC smear to fold in the random backgrounds here on this step. That's where it happens. It's done hit by hit, and by default, one random trigger event or one simulated event at the hit level. So there's a kind of a special note. This has caught a couple of people in the past. MC smear will actually be run even if you tell MC wrapper, I don't want it smeared, because it does convert, it modifies the format so that HD root can read it. And rest assured that the produced smeared file is unsmeared. And then finally, HD root. This runs your favorite plugins over the smeared HDDM file. So we've actually heard a lot already about why you don't need to make a plugin, when you do need to make a plugin, how you make a plugin. This is the HD root application that actually runs Jana with the various plugins. After you run this, you should get root files and or trees so you can merge and do further analysis. Monitoring hiss, for example, will produce monitoring histograms or various histograms based on your sample. It happens here. Okay, so how do you get MC wrapper? Actually, if you're using build scripts, as Marquito mentioned in Talk 1, GlueX MC wrapper, if you're using that standard build, you already have it. It's actually probably already in your path, too. It contains no compiled code, MC wrapper itself, so you don't need to worry about how do I build it. You don't have to. So how MC wrapper works to get that production chain done is essentially takes a config file and a command line, and then there's a script called gluexmc.py, and its job really is to just interpret the options, configure the script, and then run. So this is actually where it decides to utilize Swift, or run on the OSG, or run on QSub at CMU or William and Mary. So basically the batch system decision comes, or gets, the submit file, actually gets made by this guy when the job needs to be submitted. Basically the make MC script is the engine of everything. It takes in things like gcontrol. This is just a templated control.m file from Richard's examples from way back ago, a long time ago. It also finds the other needed files it needs, other files it needs to get the job done. Maybe they're the parameters. It figures out from the RCDB what the coherent peak position was or whatnot. So it gathers up all the resources needed and actually does the production. All four of those steps, generation and simulation, smearing, and reconstruction, all happen here. And then you get output, and it'll put in the output directory. If you're using a group build, this doesn't really apply. You shouldn't have permission to do this. Don't run MC wrapper from the MC wrapper central directory. It's just needlessly messy and can cause other problems. Here's the command line. I don't want to go through all of this. It's in the documentation in more detail. But I did want to bring a couple of the options out. This per file. So if you're running, you can say, I want per file to be 10,000. If you wanted 100,000 events, you get 10 jobs or sub-jobs, each with 10,000. If you set it to 50,000, you get 2 sub-jobs, each with 50,000. And then this batch, where essentially you can tell it, no, don't use batch, default to 0. Yes, submit it to batch. Or for Swift, it's a little special. If you remember from Alex's talk, you had to do Swift run your workflow. So you have to create your workflow, and then you have to run your workflow. And if you forget to do that, you'll come back after lunch and realize nothing is running because you forgot. Batch equal 2 basically tells Swift, not only submit it, set up my workflow, create it, but run it after you're ready. So an example of running, you issue a command to GlueX MC with your config file, which we'll get to in just a second, as well as a run number or a run number range. I can talk a little bit more about that very shortly. How many events you want, and then the command line options. Order doesn't matter with that. So this doesn't really, I figured this would be all washed out. Essentially all of the options are in one place. It's either in the command line or it's in this config file. The kind of methodology that I used is if it's something you're going to change a lot, like I'm testing on run 30496. Now I want to compare it to run 30730. That's something you can just iterate on the command line. If it's something that's a little bit more analysis specific, like I'm using this generator because the decay I'm looking at is whatever is given, you're probably not going to change that with each iteration. It's essentially broken down into 3 parts. 2 lines up here give you really fine-grained control. Very few people end up needing to use this, but it's there for completeness. A block, this is telling all the different parts how to run, how you want things to act. The ones that are uncommented are essentially the only ones that are needed. So that would be your output directory, number of cores, generator, your config file, those kind of things. And then down below is used for batch submission. Note, use full paths. It's a good habit to be in, depending on where you're running it. You might be in a directory that has that name, and it's going to try to use that. I really recommend when you have the generator config, you put the full path to the config file itself. Here I've listed the kind of most important options. The output, this is the full path to the output directory. MC Wrapper will actually create the last directory if needed. So you can put in your final path. You don't already have to have that final directory. For example, in this case, output. You do not have to have output made. It will make it for you. Generator config. A lot of the generators actually contain hooks that I think make your life easier. So there's actually inside MC Wrapper Central generators, there's a folder for each generator, and inside that there's examples, an examples directory, which will give you kind of templated config files. So for example, bggen actually is completely templated, and you don't have to have your own copy and modify it. But you can if you want. That's not a problem. The background choice is important. There's none. This just removes all the background. There's the beam photons, which I mentioned before. It just kind of represents an EM background. This is the tag only. It's the same as beam photons, but like just to the tagger part of things. And then the preferred random. So this is that random trigger that I was talking about. You have to feed it in by saying I want randoms, and then you have to give a sim recon tag. This is old. It's really now a recon tag. I'm trying to keep it consistent. So this is the tag of the reconstruction, which generated the random triggers so that you get the same hits in both cases to keep things consistent. And finally, you can either give a comma-separated list of plugin names, or more powerfully, as we've seen, you can make a config file for Jana that puts your extra cuts, your reaction filter, defines the reactions you're looking at, runs 6 different plugins, and gives all the options. That is kind of my preferred way to run, but if you're just looking at some basic stuff, you don't have to do all of that. What does the output look like? That's often a very important thing. Inside your data output base directory, you should have 3 or 4 logs come from being in batch mode. But you have configurations, HDDM, and root. So for example, in configurations, there should be a JONT and a generation. These contain the control.in file, which JONT needs to run. And this should be a copy of the one actually used. So if there's some strangeness, you can look there. HDDM is your HDDM. Root actually is separated by source. And there's a note there. Here are some other helpful tips. I'm going to be a little short on time. It's more here for completeness. There's some special options. It's recommended if a job crashes when you're testing interactively, remove the folder it created. I don't do that because I don't know if you need to look in it to figure out what's wrong. So this can actually cause some stomping. That's a problem. Now, very, very briefly, I want to introduce MC WrapperBot. Essentially, this is centralized production. It doesn't allow this fine-grained control. Not all the options are parroted there. You can't do custom generators. You can't do JAWT special flag settings. But a large amount of this production actually doesn't need any of that. So if you're doing generic MC, if you want acceptances of a channel, you may want to use MC WrapperBot. It starts with a submit form, which has basic pieces. I'm going to spend like 2 minutes clicking around just to kind of show what that is. If after you submit a request, you should get an email confirming it. And then the robot will actually test your job, or your project, sorry, with a chosen software stack, thanks to build scripts. If it fails, you'll get a log. It has some self-help servicing. Your request then is broken up. The robot kind of decides how best to do that. It's empirically optimized right now. The jobs are submitted. They're monitored. When it's complete, including the transfer of data, you should get an email that says, hey, got your Monte Carlo. This is what's going on behind the scenes. This is the anatomy of your job. You can look at it here. There's a lot of moving parts. We're going to go to the web page for like a minute, but just in kind of conclusion, I wanted to point out this is a link to an overleaf. It's a work in progress. It's the documentation, all of the options and command line. If you need any extra help, you can email me. You should be able to go forth and make some Monte Carlo. So the gist of it is these are often the common, it's cut off over here. This is the common options, so you can switch between a number or a range. You can provide an RCB query for that range, give you a number of events, pick your generator, select where the config file is. Switch between JAWT versions is that easy. And then you can confirm and ultimately submit. You'll be sent to, you'll be given a link that will send you to a page that looks like this, which contains all of the active running jobs. You can right-click to get options about interactions with these jobs. And if you left-click, you actually can get, just as an example, here's a job or project Alex requested. And it gives you all of the different jobs, where they were run, and kind of everything you could want to know. That's Monte Carlo at GlueX in a biased way.
A bit biased. Have we solved this issue dealing with being able to generate Monte Carlo and reconstruct it with a certain version of REST, but then process the analysis with a different version?
Not yet.
Okay.
That is coming.
In the context of MC Wrapper, right? So of course one can always.
One can always do this by hand,
Yeah,
but it's impossible to do anything by hand. So that's why we have MC Wrapper.
Yeah. So,
I'll make some other mistake if I try to fix that one, right?
So Matt's referring to these analysis launches that happen have a certain set of analysis libraries, which are contained in the HALD recon repository. But that's also the location of the reconstruction code. And remember that we do reconstruction launches, we do analysis launches. They could have different analysis libraries. Currently, you cannot run. You can't run the analysis library in a different HALD recon than the reconstruction. I think next software meeting we're going to be talking about the long-term solutions for this. for now, the latest the latest analysis launch, I talked to Alex, and he promised to use the same Haldy recon version. So the files that I sent out in the email actually use the same version, but that's because it was contrived to be so. A solution will be implemented as soon as.
That's just for this latest low energy data, right?
Yes, yeah. Just this one. Anything before that, run over the Dan arrest. For now, when we have a permanent solution, certainly it's top of my solution.
This is another advantage of having these kind of archived REST files, Monte Carlo REST files that correspond to the various major REST productions. And then this happens automatically. You just rerun the analysis code.
Yeah, no, I mean, every once in a while, like I remind Thomas, like, hey, where you should generate BGGen or something like that. I mean, so part of the problem with some of the things that you were mentioning before,
yeah.
I mean, I think it's a good idea, but, the problem is that BGGen, for the concrete things that we're trying to do right now, is not always that useful, and in general, I think that we need to do a little bit more work so that we have a good library of actual production models.
But there is another concern. I mean, the reason we separated Haldy Recon and Haldy Sim is because the simulation just continues to advance. And we want to have the latest version of the simulation. Real changes.
Yeah, that's right. So that, yes, you can remake that file.
Yeah.
But so, yeah, you make changes to the simulation. You improve the simulation, but then you keep reconstructing it with the same old reconstruction code that you make the production data with. That's right. Yeah,
right.
Yeah. And then you have to analyze it with whatever you've analyzed most recent analysis.
We have, I've thought about doing some kind of automated where every time you add an analysis launch, you're gonna want Monte Carlo, right? So at least in
people
those
don't
instances.
seem to now, and I argue that that's a problem. We should get in the habit of using it more.
But it can get into, you have somebody who submits 3 reactions, they don't actually look at one, or it's an error, and then you're producing. There's lots of other potential things that could clog the system rather than having people then do Monte Carlo when they need it. I would be interested in automating it all, but
As a sort of a stopgap, we could have people, when they submit a reaction to the analysis library, they could say, what is the proposed, subchannel masses you want to look at, and then, tell us what type of Monte Carlo you would want, and at least we could then catalog what the requests are and see how that fits into packages we have, like GenAmp can do pretty arbitrary generation, but we kind of need to know what people want to look at in those channels to.
And I agree with what you're saying about the generators too. BGGen is not, but at least BGGen would let you figure out what the dominant backgrounds are for topology. How frequently do you have an extra pi zero that's floating around here? Or at least at some level, right? You can get some idea, yeah.
Okay. Any other, Dave?
How do we generate random triggers? Take enough of them?
I think we do take enough of them. So random triggers, when we're taking data, there's just a front panel trigger.
100 hertz.
Yeah, 100.
100 hertz.
Is there a beam cut before you mix them in?
Done what?
Yeah. So the triggers are taken so that they're explicitly out of time with the delivered beam munches, right? So the idea is to try and get.
But I mean, when the beam is off 20% of the time, and there's a bias tracking reconstruction.
But yes. So then.
Oh, you mean a beam on cut?
Yeah, sorry.
Yes, when the files are generated, so we do cut on this information, so that we're only taking. Yeah. So that we only save it when we know that the beam is actually.
The run is simulated according to the run conditions of that run.
Right. That's right. You need to cut on the beam being on.
But within a run, you only put random trigger events into this file you mix with if the beam was on during that time.
So there are 2 types of you imagine just noise that's out of time with the beam. You can imagine electromagnetic background that's in time with the beam. How do we manage these 2 cases? So you're completely random 100 hertz that's not synced to the beam at all. Seems like that handles the noise.
The beam structure is short compared to anything we look at. Like the windows.
That's right. Yeah. Well, Yeah.
And the drift time.
Definitely for tracking. Yeah, definitely for tracking.
Even
Yeah.
for the PCAL. I mean, maybe not the EPCAL. I
Yeah,
don't
definitely for tracking. Yeah, you're right. Yeah, but not for some of the scintillator detector, the FCAL.
But we do synchronize the random triggered event to the generated physics event, such that like the accidental taggers line up.
Yeah.
So the accidental peaks are 4 nanoseconds away. So Richard has a scheme when he does the mixing that he shifts the whole event until you get an alignment between the signal peak, timing peak, and the one of the out of time peaks. From
Right. Okay. So he tries to line up the precision timing detectors.
Yeah.
It has to be there. You can't get the accidentals, right?
Yeah, and if you look at the after you fold in the randoms, you can see the out of time peaks there. So there's a, unlike earlier iterations where it was just a flat kind of pedestal. So that has been polished.
Any other questions? Okay, thanks.
Yes. Somebody online?
Yeah.
Did someone have
I
a
was
question
going to
online?
give just a small question. Nasser. Thomas, I was just wondering when you said you cannot see below 6 GeV because I don't see this also in simulation. You said that it could be due to some truncation on the CCDB. Can you explain a little bit what's happening?
Do you want to handle it?
Yeah, the paraspectrometer doesn't measure beam photons below that energy, and so we don't measure the flux below that. And so when we generate based on data, we have no information about what the flux is below that energy range. So if you're generating based on our known measured photon flux, we can't generate events below that energy value of around 6 GeV.
If you have a specific need, then in your MC config file, you do flux_2_gen equal cobrims, and it will bypass this limitation.
Right, so you can generate from a theoretical distribution all the way down to 0 beam energy if you want.
And related to MC wrapper, so if you submit the form, how is the solution from there?
Can you submit cobrims via the webpage?
Not yet. It should be coming soon. Had this whole collaboration meeting thing that kind of.
Okay, so it's a feature request.
Yeah.
Thank you.
Right. Oh no, everything is very small. And I have to